The movie set for The Lord of the Rings is a dramatic example of earth-sheltered design. What this kind of design involves is putting your building either partially below ground or totally below ground. And that means it involves either cut or fill. Just like in excavation, you're either going to have to cut into a slope or you're going to have to fill over part of your building. And by the way, you see the name Malcolm Wells down here. The late Malcolm Wells was a big proponent of earth-sheltered design. He devoted his career to it, and he did some beautiful watercolors. So you're going to see a lot of illustrations from him in these slides that follow. One of the advantages of earth-sheltered design is that it uses less energy because the temperature below the surface of the earth is more constant the deeper you get. What you're looking at here is a temperature graph from Norbert Lechner at Auburn University, and this squiggly line at the top is the surface of the earth. And we see here on the left the average winter temperature. It's very cold. And then we see here on the right the average summer temperature. It's hot. Then we see those two temperature lines begin to come closer and closer together as we get down below the surface of the earth, until the difference in temperature from winter to summer is small the deeper we get. So what this does is reduces your energy load. You have less heat load in winter and less cooling load in summer. If you start with a site that's already sloping, you will do less excavation because you can just dig into that sloping site. We'll look at a picture of a winery that this architect Allison Kwok did. Be aware that earth-sheltered design does need insulation, and we have a question about this in our worksheet. It does need insulation. Earth is not a good insulator. I give you some R values here, for example. A whole foot of earth has the same R value as only 1 inch of wood. It's not a good insulator. You still need insulation in your building. Here's the winery from Allison Kwok. So this building is cut into a sloping site, and you can see how this design might be able to resist windstorms, and it might give the building an ability to withstand fire better than a freestanding wood building. Moisture is your biggest challenge. And you need to think about two things. One is drainage, as water is seeping through the soil here, and it will do a lot of seeping. You have to have foolproof drainage. You also have to be concerned about condensation. And here you would want to consult with an architect who knows about such things. You can install your earth-sheltered design in a variety of ways, from all the way below grade to up on top of the grade with a berm. Below grade gives you the biggest benefits and also the biggest challenges. At grade, cut into sloping land, can be easier to build with. It also provides good access for people and for sunlight. And if you're facing south, it's easy to use passive solar heating. With bermed design where you build a berm around the building, you can start with flat land and then build an earth mound around it. That's what we're seeing here. This is the Parliament House in Canberra, Australia, and you can see in these several pictures here, you can just see how they've built up the berms. This one is good for hot, dry climates. Think about what you know about those climates. Here's a lovely example from Iceland of houses that have a combination of berms and then green roofs made of sod. This is the late Malcolm Wells art gallery at his house. And you can see here on the right side the slope where his art gallery is built into the slope. So you can think about whether you're more worried about heating or whether you're more worried about cooling. If you're worried about heating, then you might want your open part of your house to face south. If you want to keep cool, then you might want to face north, if you're in the northern hemisphere. Earth-sheltered design works the best in hot, dry climates and in places with big temperature swings between summer and winter. It works least well in hot, humid climates. Think about the southeastern United States, for example, or subtropical climates. And think about what you know about buildings that are suited for hot, humid climates. You want thin walls, lots of open spaces, maybe even up on stilts where the wind can blow through. So an earth-sheltered design is the opposite of that. And here are some sources for you, places where you can find out more about earth-sheltered design.